Today, China produces more scientists than any other country. And many of them are leading their fields, pushing advances in medicine, robotics, radio astronomy, high-energy physics, quantum computing, and cosmology. From reinventing food production, helping to feed almost 8 billion of us, to tackling global diseases, and building a more sustainable society, China is increasingly engaged with today's global challenges. And from deep sea to deep space, they are at the vanguard of human exploration. Their work is not only shaping the future of China, but the future for all of us. And the stories of their scientists are our stories too. Welcome to a new age of Eastern science.
Let's turn over. Rolling.
Science is the driving force that's changed society the most in the last few centuries. From advances in genetics and biotechnology to computing and communication, our breakthroughs are all driven by one thing: curiosity. This is the story of 7 scientists in China who've devoted their lives to being curious in the quest to discover the nature of life, chart the oceans, explore worlds beyond Earth, and dive deep into the quantum world and the atom.
I think every piece of knowledge is useful. It's just like a building. You have a lot of bricks. You cannot say which brick is important. So we are just trying to contribute to add one more brick for the building. My name is Yifan Wang. I'm explorer of atoms. If you think about the whole history of the science is actually going deeper to the structure of matter. So we managed to understand the atoms. We managed to understand nuclei. And now we're trying to look at the elementary particles. So it's a step by step. The elementary particle physics world is actually made of 12 particles we call the fermions. And these 12 particles actually made up our whole material world. Among these 12 particles, we have 3 neutrinos. These neutrinos are the lightest elementary particles and actually play extremely important roles because all the heavier particles in the end can decay into the lighter neutrinos. So neutrinos are the most abundant type of particles in the world. Neutrinos are around us everywhere. I mean, the sun is a neutrino source, the earth is a neutrino source, and even human beings are neutrino source. They are around us everywhere in the universe. In every cubic centimeter, there are 300 neutrinos. So it's huge. But neutrinos have very little mass, so neutrinos going through the Earth can easily pass without any interactions. So it's very hard to detect them.
Yifang's first neutrino detector, built in China, at a place called Daya Bay, allowed him to measure an important property of the neutrinos coming from a nearby nuclear power station. It captured headlines around the globe and put China on the world stage of high-energy physics.
To be honest, this was the first major discovery I ever had in my life, so of course it's very, very exciting. During the process of the Daya Bay experiment, we realized that you can actually measure another very important physics parameter to understand which neutrino is heavier.
Yifang's new detector, designed to measure the elusive mass of neutrinos, is under construction deep underground in southern China. It's known as the Jiangmen Underground Neutrino Observatory, or JUNO for short. And it will eventually be the largest, most sensitive neutrino detector ever built.
You have to design your detector with sufficient shielding so that background neutrinos are not coming into your detector. You have to have something like 400 meters of rock above your detector to shield cosmic rays. So we need to dig a sloped tunnel going down because we need a huge underground cavern. The diameter is one of the largest in the world. It's 50 meters. And then in the cavern, we build our neutrino detectors. Underground laboratory is very difficult because we had to control the water out from the rock in a very, very careful way. And secondly, going deep underground, the rock temperature increases. Indeed, at our experimental site, the rock temperature is 30 degrees. So this requires a lot of ventilation and heat removal, and this, of course, is another huge difficulty.
Working down here in these conditions for up to 12 hours at a time puts a great stress on the construction team. Already 4 years into the excavation, the hardest part of JUNO is yet to come. Building the instrument that will detect and weigh the elusive neutrinos.
In addition to the civil construction, the detector itself is unprecedented. In JUNO, this is a factor of 1,000 larger than our diabetic detector. This is the largest ever built in the world. So we have to worry a lot of things which we never thought of. For example, whether it is safe during the earthquake. And all of this, actually, nobody knows how to calculate. So we had to figure out from the first principle and calculate all these effects and come up with a design. And we believe it's feasible. Of course, difficult, but the jump, we believe, is achievable. These neutrinos are just one subfield of science. But there's no doubt that we should pursue this kind of pure science-related knowledge, maybe to help our world.
Our quest for new knowledge spans the planet. From the deep underground exploration of subatomic matter to Earth's deepest oceans.
As a scientist, you want to know nature, know the world, know the universe. My name is Wei Chen Cui, and I'm the explorer of oceans. "对那个海洋科学家来说，现在我们对地球，尤其是海底的那个底面的这种了解太少了。我们现在人类对海底的了解，跟月球表面，甚至跟火星表面，我们甚至都不如。为什么那么不了解？因为我们没有很好的装备。我们现在要研制的这个彩虹仪的载人潜水机，目的是为了帮助科学家反复的下去，反复的勘探，让他们去做海洋科学的研究，让他们来开展这样的工作。海底的地形地貌的数据做到现在给出来的狗狗的地图一样那个清晰的。
Their new submarine, Rainbow Fish, is still being prototyped, but Wei Cheng is confident it can be built. As one of the designers of China's first deep-sea submarine, Qiaolong, and one of its crew, he's familiar with the challenges of the deep.
我自己很早就对这个生死的概念已经是想得很清楚了，所以就是在我的心里边，从来没有任何地方就是有那种害怕、恐惧的心理。我们现在下去的过程中，对吧？海水里边就像雪花一样，从你窗户面前飘过，跟在晚上看到繁星点点这样的这个感觉，实际上很相像的。然后我们特别要关注的，有什么异常的响声。如果说我听到左前方有个什么声音，那这一次估计有个什么设备可能坏掉了，或者压碎了、压坏了，或者是什么注意。
这是蛟龙呼叫，蛟龙呼叫。我们现在已经到达了马里亚纳海沟海底。
The maximum pressure there is 11 tons per square centimeter. So the pressure at the main cabin is very high. 7000米，我们大概花了3个半小时。一般都要到潜水机接近海底以后，我们才开始把灯打开。总体上来说还是比较荒凉的，生物还是比较少。自己下去那一次，我们是航行，还没有看到那个鱼啊什么。因为我们的那个坡度是这样，就是越往前、越往深的走，它是下坡，这样下坡呢就是看得很清楚。后来我们掉头往回开的时候啊，它是上坡，驾驶员没有经验。他自己就是跟着感觉开，可是你这个那个推力器一转的时候，把海底里边的这个淤泥啊就积浑了，浑了以后就看不见了，看不见了，凭着感觉开，突然潜水机不动了，然后驾驶员当时蛮紧张的，知道我们的潜水器可能就是手部插在那个底里边被夹住了，然后他就把推力器换成功往上拔。先换成一个那个小档，结果潜水艇还是不动，卡得死死的，所以当时就是还是蛮紧张的。哎，开到最大档的时候，潜水器稍微一点点往上动了。实际上后来因为发生这个小的事情，我们就说提前回来了。蛟龙号里边想要改进的，在我彩虹项目里怎么进行改进，把这些经验教训都把它那个吸收过来。可是深渊海沟从6000米到11000米，蛟龙号只能到7000米。以后我们真正要用的这个科学研究，最大的深度要到11000米。所以我的这个彩虹鱼挑战深渊极限项目的主要的目标。就是研制出无人潜水机、着陆器、载人潜水机能够在所有的海洋里边能工作。I dived to 7,000 meters. I wanted to be the few people to reach the 11,000 meters. And there are many other oceans, deepest point human beings have never been there. Which I really want to explore myself.
Our planet's rich biosphere is underpinned by one extraordinary molecule, the stuff of life, DNA. And its exploration is driving bold advances in biotechnology around the world. As scientists map the genomes of an increasing number of Earth's organisms in a bid to improve them.
this genome editing tools can be a revolutionary technology. It's changing our life. My name is Caixia Gao. I'm a plant biologist, so I think quite a lot about how to make a crop improvement. For the past so many years, we use conventional breeding to improve crops, but we could only introduce some traits that are available in parent plants. And it takes also many years to get these desirable traits into the new plants. So now if I compare to that new genome editing tools, genome editing can speed up plant breeding by allowing the introduction of precise DNA sequences in plant genome. CRISPR was invented in 2012 as a new genome editing tool. There are actually two problems to edit plant genomes. The first one, how to cut DNA, and the second one, where to cut. So CRISPR consists of two parts. One is guide RNA, which matches perfect with DNA sequence we are going to cut. And the second, we need to deliver a molecular scissors to make a cut. So the guide RNA will direct this molecular scissors, we also call it Cas9, to the right place and make a very specific cut. We mix those liquids and deliver that to the cells. The guide RNA is floating in the liquid, so we had to find some way to send it into the plant cells. In this case, we chose gold particle. Gold is very heavy, and with this very tiny particle, we could put this guide RNA liquid together with gold particle, and we use high pressure air to push this gold particle into plant cells. So then we need to move this edited cell culture into tissue culture room to let them grow. And once those edited cells grow into seedlings, we need to move them to the greenhouse. And in the end, or the last step, we need to move them to grow the plants in the experimental station. So the benefit of using this genome editing technology, we could develop many new applications.
One of Taixia's goals is to improve the nutritional value of our food, trialing the technique by creating a new variety of tomato.
For tomato project, we are trying to increase vitamin C content. Vitamin C is an important nutrient for humans. So in our project, we take some vegetables and fruits, such as tomato, and we use genome editing technology to increase vitamin C content.
Food waste is another problem Taixia and her team are tackling.
Using this technology, we are also trying to prolong the shelf life for strawberry by knocking out one gene. So the longer shelf life means also the less waste.
It's not just supermarket food waste that Taixia's team are working on. She's also fighting food waste caused by diseases, such as powdery mildew, which decimates wheat crops across the world.
The yield decreases by like 30% because of this disease. Currently, this disease is controlled by using heavy fungicides, which is not good for environment and which is not good for people's health. So we made a project using genome editing to create a disease-resistant wheat. It was very hard, to be honest. Every day when I wake up, the first thing I thought about, what's a new achievement we have got in the experiment? So it turned out once we knock out this gene, then we are able to generate resistant wheat plants. So we don't need to spray fungicide anymore. This possibility is so unlimited. The future is unimaginable.
Technology usually advances in small steps. But there are fields in science and engineering which are on the brink of making giant leaps that could change the world in dramatic ways. One such field is quantum information, a technology that many countries, including China, are now racing to develop.
Our quantum computer system can do something much faster than the state-of-the-art supercomputer. Quantum computer will be a standard tool for all scientists. Our technology could be used for many, many other fields. I am Jianwei Pan. My major focus is in the field of quantum physics and quantum information. I would like to give a short example to explain the strangeness of quantum mechanics. So suppose you have two entangled particles. Then when they're separated, as long as these two particles are entangled, then this state of one particle will be transmitted to the other one. So it will be a perfect correlation. If you do this in the laboratory, so they are so close, then maybe they have some sort of interaction. But the thing is, the degrees of the distance, they are separate far, far away. And you will see, as long as this particle is in a state of 1, then the other one is also in state of 1. If this one is in state 0, then the other one will be in state 0, no matter how far away they are separated. So this is a weird thing of quantum mechanics. So people keep asking, why could it be like this? I really want to understand. But whenever you read more, you are more confused. So that's the real problem.
In an attempt to better understand quantum entanglement, Jianwei Pan and his team came up with a bold experiment to see if entangled particles would remain entangled when over 1,000 kilometers apart.
So the basic idea is we have entangled photon source installed on the satellite. So the satellite will send two entangled photons to two ground stations, which are separated with a distance on the order of 1,000 kilometers.
With ground teams waiting at observatories spread out across China, the group held their breath.
Our expectation is 99.9% quantum mechanics is still correct, but still is 0.01% or something like that. So we want to see some deviation. Then we really find something great. Then people need to reformulate quantum mechanics.
With their satellite in position high overhead, the team prepared for their historic experiment.
We have to solve lots of problems to make sure the light is always pointed into your eye from the sky. We have to develop lots of advanced technology so that we can send in the two photons precisely to the two ground stations. Then afterward, we perform measurement on the received single photon. So in our experiment, we managed to show this strange phenomenon over a distance about 1,207 kilometers. So it's really far away. This is a phenomenon in nature, but we don't know why or how this happened. But we are super happy because our technology could be used for future application of quantum communication.
And the application Jianwei Pan and his team chose to attempt was to harness the long-distance quantum entanglement they'd observed to create an uncrackable encryption key.
So another mission for the satellite, we think we need to use entanglement to encrypt your message, your picture, or your video. So therefore, in 2017, we managed to ensure the secure information transfer over a distance of 7,600 kilometers between Beijing and Vienna for a video conference between both President of China Academy of Science and the President of Austrian Academy of Science. So you first generate a secret key, then you perform the encryption to send your video message. So he is the only person who can read out this secret message, no one else. And actually, if you have eavesdrop is some sort of measurement. So if someone measures in between the quantum channel, then the state will be changed by the eavesdrop. So you know there's someone already performed eavesdropping on your key. Then you throw away the key.
This emerging field of quantum information promises radical changes in society, perhaps eventually powering a revolution in computing as well.
In the digital classic or modern computer, the basic information element is a bit. So for each bit at a fixed moment, it can only be either in 0 state or 1 state. But however, for a quantum particle, a qubit, then it can have 2 states memorized in the same bit or same qubit simultaneously. But now if we have 2 quantum bits, they can be in the position of 0, 0, plus 1, 0, plus 0, 1, plus 1, 1. Then you already gain a factor of 4. So then if you increase the number of qubits, then you really gain enormous computational capacity.
By scaling up the potential for doing calculations in this way, with just 50 qubits, you get more possible combinations than there are atoms in the universe.
This is precisely the reason why quantum computer can be so powerful. Its computational capacity for some specific task can be, I think, 1 million times faster than the total computing power over the world today. Of course, it may take 30 years or even 100 years to have a universal quantum computer like we are using today. For the whole quantum technology field, we are still at the early age. But I think the race really already started.
One field that could benefit from the complex modeling that quantum computers could excel at in the future is the impact that climate change will have on all of us as we seek solutions to living more sustainably. As the number of people on Earth pushes towards 10 billion, we'll need to produce as much food in the next 30 years as we've done in all of human history. And that will require an altogether different approach to farming.
气候变化会给农业的生产带来极大的不确定性，极端灾害天气，例如高温、干旱以及洪水等等，都会给农业生产带来致命的打击，会使植物的种植区域发生改变。 我们希望能找到一种新的农业生产的方式。My name is Gong Huaqing, and I'm a farmer. But this is not farming like you might imagine. It's a farm of the future. I'm part of a team that is pioneering a new kind of food production. A production that might one day feed us all. China has to feed 1/5 of world people with just 7% of world arable land. So we try this new experiment. We are attempting to produce more crops in less space. The farm has 10,000 square meters, where all the environmental factors such as lighting, nutrition, humidity, temperature, and gases all can be controlled to produce quality vegetables. 植物生长它所需要的能源都来自于阳光，所以说光对植物的生长是非常重要的。那这里的话呢，我们就为它们生长不同阶段去设计不同的光谱，来适应它们的生长。比如说在苗期的话呢，植物它需要更多的蓝光；成长的后边的阶段呢，给它多一些的红光，会让它生长得更快。那植物的话呢，它所有一些必须的营养元素，在营养液里必须给它提供。营养液是会不停的循环的。那从模组上面这个营养液呢，依次流下，经过植物的根部，然后逐渐流下，回到这个营养箱内。那这样不断的一个循环过程，可以节省我们在栽培中间水的用量。我的工作呢，主要就是为植物的生长给它配置合适的营养液配方。一些必须的营养元素，如果发生缺乏或不足以及过量的话，都会对植物的生长造成影响，引起植物的失绿啊、发育不良啊这一些的症状。那这个时候的话，我们对营养液就需要进行人工的干预了。那经过几年的辛苦的研究工作呢，我们筛选了超过1000种的蔬菜品种。从中间挑选出100多种可以适合于目前人工光下边的水培系统。那我们相信，在未来，在植物工厂里边，我们可以生产越来越多的蔬菜。目前这个工厂的话呢，因为还没有完全实现自动化，所以整个工厂大概需要接近50个人来运行。那其中的话，超过1半的人是集中在蔬菜的采收和包装。如果能在采收和包装的环节再能实现自动化，那我们相信在未来运行这样一个工厂，大概只要1到2个工人就足够了。目前在这一栋工厂里呢，每天可以生产1.8吨的蔬菜，这个量的话呢，可以供应5000人的蔬菜需求量。根据这个产量，我们可以想象，如果是一栋占地1万平米的100层的高楼，每一层楼都用这种6层的模组来种植蔬菜，那么总的蔬菜产量可以满足50万人每天的蔬菜需求量。这种技术可以成为未来我国农业的一个重要组成部分。
Beyond this world, human curiosity compels us to peer out into the cosmos, building machines to look further, to see more of the universe than we've ever seen before.
We live in this wonderful, rich, and active universe. And as an observer, we want to know more. Our job is to explore the universe, try to find the known unknowns and unknown unknowns. I'm Li. I'm an explorer of radio waves from the cosmos. Radio astronomy is just this wonderful playground. Because if we look up in the sky, we see the Milky Way, we see the sun, we see many, many stars. On the other hand, most of the cosmic material exists in this so-called dark state, invisible to human eyes. But they emit low-frequency radio waves. We just need the proper eyes or ears to listen to them. And the radio telescope is the instrument to try to catch that low-frequency wave that gives us information of those dark material. This low-frequency radio wave has a wavelength of 21 centimeter. That's roughly the size of a watermelon. But we also know that the universe is expanding, and while it's expanding, that radio wave will be stretched. It will become only 21 centimeter, it will become 30 centimeter, and all the way go to meters and multiple of meters. So as the wavelengths become bigger and bigger, we'll need larger and larger antennas to collect those waves so we can look into more distant universe. That's when radio astronomers worldwide start to come up with this concept for the next big radio telescope. That is like a quantum leap from anything we have now. So as part of that concept, Dr. Ren Dongnan and his colleagues proposed that we can build our giant dish called FAST. Dr. Ren Dongnan really drive this project from the very beginning. And he will spend basically the later half of his whole life and career of bring this into fruition. You need an area that is rich of natural depressions. Otherwise, you have to really blow a lot of holes, and that cost can rival the full cost of building a telescope. So then a couple of candidate sites was selected in this area and finally settled on this site. It's really remote. My first time here is in 2007. I came on the trip with Dr. Nan, actually. Many things in FAST has not happened before, so I can certainly feel his pressure. One of the key challenge is the panels. We have 4,500 panels. But they actually made of about 100 smaller panels, about 1 meter triangle. And they are reassembled on site. And they have to be screwed on precisely and pointed to a point in the sky. So my main concern is to carry out this major surveys. One is aiming for thousands of new pulsars. A radio pulsar is a fast-spinning so-called neutron star, characterized by its amazing properties. For example, its very large density, 1 billion tons per cubic centimeter, and very high magnetic field. And it's made up of superconducting superfluid. So it's certainly unlike anything that we found on Earth. And discovery of pulsar and the study of them bring to light the fact that such sort of unimaginable material actually exists. So we finished construction toward the end of September of 2016. And afterwards, it's really the nerve-wracking period. Because we push return and wait for the screen to update. see this short pulse, very bright, that come from distant cosmos. So we know the full system works. After that, we try to find much weaker signals to expand our knowledge and discovery of new pulsars. We got some better data, and we actually see new pulsars. I was really happy, so I sent this message to Dr. Nan. We have this confirmed discovery. I didn't get a reply because he passed away a few days after that. I still hope that he was aware, and I know that deep down in his heart he has confidence in FAST and in his whole life's work. We are poised to double the number of pulsars known, and that's largely thanks to the great sensitivity that this large antenna has given us. We can go much deeper than other telescopes. We have expanded the capability of radio astronomy, and we already start to produce science discoveries. At the end of the day, I just feel lucky and really fortunate that now we can actually measure something that no human being before has measured.
Closer to home, there are other worlds to explore. Worlds we might one day also call home. And there's one that China's prioritized most: the moon.
中国人对于月球的感情特别的深厚，因为它代表着一种温馨，一种远方的游子对家乡的眷恋。所以这些我都理解。但是月球，它是地球的唯一的卫星，它也是我们走向深空的一个跳板。My name is Ouyang Ziyuan. I'm an explorer of the moon. 1969年，阿姆斯特朗和奥尔德林登上了月球。
That's one small step for man, one giant leap for mankind.
这是人类的一大步，这像阿姆斯特朗讲的，这是一个人类的伟大的壮举。事件发生得如此的迅速，人家都搞到天上去了呀，我们还在地上爬来爬去。
Man must explore, and this is exploration at its greatest.
我坚信，我们中国虽然现在是一穷二白，未来也一定会走向空间时代。我很关注，所以我就开始调查研究。我当时得不到月球的样品，结果我开始研究陨石。我在中国建立了相关的实验室，这样的话就逐步形成了。但是经历了35年啊，很艰难的历程，我们一步一步的前进，一直到2004年国家批准中国的探月计划，最后命名为嫦娥工程。 嫦娥是中国人崇拜的月亮神。我们没有能力像美国一样把人送上月球，所以第一步我们叫无人月球探测。我要对整个月球，我中国第一次去，整体怎么样，全球性的怎么样，它的综合性的有哪些特点？所以我们第一步发射了嫦娥1号、嫦娥2号。它是一个绕月飞行的卫星。
China's first mission to the moon, Chang'e 1, left Earth on the 24th of October 2007, riding a rocket they'd only used before to put satellites into orbit.
有些意见说，我直奔月球，又怕我们的火箭能力不够，最后决定绕地球飞3圈，就好像一个运动员的链球运动员啊，他把那个链球使劲转得非常快，最后一松手，高速的飞去过。在到达月球的时候，我在大厅里面观察，我提心吊胆。这个最关键的时候来了，成败系于这一点上。人家失败就在这一点上。最后，测控向我们报告，已经被月亮抓住了。按理说这应该是大高兴，非常高兴的时期了。我说不行，你给我再复核一次。孙家栋他是总师，我是首席科学家，我们两个商量决定再核实一次。他们又核实了一次，说已经被月亮抓住了。
发动机关机，第一次进月制动结束。
我们两个老头，我70多岁，他80多岁，抱在一起，大哭一场。很激动，不是别的，我不知道说什么，因为太激动了。我们成功了，所以嫦娥1号给了我们极大的激励，充满了信心。第二步，我们要精细探测月球。这样的嫦娥3号、嫦娥4号就是落下去探测。嫦娥3号在月球的正面，嫦娥4号在月球的背面落下去。而你要落在月球背面，只有一个办法，我地球上看不见。到了100米的高空的时候，我们请他自己选一个地方落下去。月球背面没有那么多海洋平缓的地方，都是高山峻岭。我们悬在那儿照相，立即判断不行，你再挪一个地方。他又再挪，最后他自己选了一张落下去。他一落了地以后，我简直蹦起来了，跳起来了，4条腿搭在一个平面上，太妙了，我们很庆幸啊。
Chang'e 4 touched down on the far side of the moon's southern hemisphere, in a largely unexplored region, only studied before from orbit.
月球背面谁也没有落下去，表面的环境是这样是那样，但是你没证据。最后落在地方，它叫埃肯盆地，是41亿年以前一个小天体砸在月球背面上， 挖出了一个巨大的盆地，它的直径2480公里，多大的一个坑啊！他挖出来的40亿年以前最古老的石头，全部给你拨开了，太妙了！我就要飞到那儿去，就要落下去。月球车就在上面走，走一个地方测一个地方。月球最古老的历史。今年我们计划要完成采样返回，嫦娥5号、6号将要把样品带回来。这样的话，我完全有把握把中国的航天员送上月球，开展载人登月、建设月球基地等等的活动。我毫不怀疑。当然，我们比人家阿波罗晚了半个多世纪，但是没关系，我们自己底子差嘛。我们中国就是这样一步一步的走下去的。我也坚信我们中国未来一定能够实现的，并不遥远，是这样的。
Follow me now, there is somewhere I want to go. You know me well, and that is how it is, it is, it is. You don't know how this came to be.